please welcome Terry Guo, founder of the Yongling Foundation and the father of ChatGPT, co-founder of OpenAI, Sam Altman。我们请台上的贵宾先看向中间的镜头。Let's firstly look at the cameras in front of you. Let's have a photo together. 先看向中间的镜头。接下来呢，请看向后方 and in the back 后方的镜头。And then to your right， 接下来看向右边，您的右手边。我们右手边前面也有媒体记者朋友们。And to your right， 接下来请看向左手边 and then to your left， 看向左手边。接着呢，我们想请郭台铭先生带领台上的贵宾一起比个赞，好吗？再次看向我们中间的镜头 ，Thumbs up everybody for the second group photo。好，先看向前面大辉摄影师的镜头，我们后面后方 ，and in the back。And then to your right， 看向右边。And then to your left， 看向左边。And back to the middle for the last one， 再看向中间最后一张。各位贵宾，我们再次掌声欢迎我们今天论坛的贵宾以及我们重磅级的讲师。Give it up once again for our speakers on the stage. You may return to your seats. Thank you so much. 我们请台上的贵宾可以先行回座，谢谢。You may return to your seats. Thank you so much. 有请。接下来论坛一开始，让我们有请主办单位永龄基金会郭小玲执行长为我们开场。Now for the opening remark, ladies and gentlemen, please welcome Shirley Guo, CEO of the Yongling Foundation. 掌声欢迎。
Good afternoon, everyone. I am Shirley Guo, the CEO of Yongling Foundation. I'd like to invite all of you to today. We have our speakers, invited guests, and everyone here today in person as well as online. Thank you so much for taking the time to join us today. Yongling Foundation was founded in the year 2000, and since then, we have always kept our eye on the future. We have worked tirelessly to push for fundamental change and long-term impact in places of need here in Taiwan and around the world. In education, we launched Yongling School of Hope with the goal of equalizing basic education for underprivileged kids. We have teachers, social workers, and created our own teaching materials and teaching training courses to support each and every one of our students. As of today, we have helped over 160,000 students, many of whom have gone on to bigger and better jobs in society. In philanthropy, we have stood in front of the front lines of disaster. In 1999, the biggest earthquake in recent Taiwan history, where over 50,000 houses collapsed, we were there to help rebuild. In 2009, one of the most disastrous typhoons wiped out entire towns, misplacing hundreds of families. We were there to meet their needs. In 2021, at the height of the COVID-19 pandemic, Yongling Foundation Yongling Foundation and Foxconn Group donated 5 million doses of the life-saving vaccine to help protect the people of Taiwan. In health, we have built a cancer hospital, the National Taiwan University Cancer Center. It is a state-of-the-art facility providing most advanced treatment practices available internationally. The Cancer Center aims to offer precise treatment and personalized regimen to all cancer patients. Fast track to today. At the verge of the next technological revolution for mankind, we are here. We had the Industrial Revolution in the 1800s, the Computer Revolution in the 1900s and early 2000s, and now we are facing the Artificial Intelligence Revolution. We understand the importance of AI to the future of the world, but most importantly, to the future of Taiwan. For this very reason, we are hosting this forum today that is absolutely free to everyone and anyone who wants this knowledge. We have over 1,000 people here in this very room, and the entirety of this forum will be available via Yongling's YouTube channel and Facebook channel for those who are not able to join us here live today. I was told that this event has reached full capacity in just a matter of a few days, so thank you for that. But obviously, this is because of our esteemed speakers that are here today. I know that every one of our speakers here today are already leaders in their respective worlds and are famous in their own right, so it is my great honor to give each and every one of them a proper introduction. So our first speaker today is Dr. Andrew Ng. Dr. Ng is Managing General Partner at AI Fund, CEO of Landing AI, founder of Deep Learning AI, chairman and co-founder of Coursera, and an adjunct professor at Stanford University. He is also authoring and co-authoring over 200 research papers in machine learning, robotics, and related fields. He was also the founding lead of the Google Brain team and chief scientist at Baidu. Dr. Ng now focuses time primarily on his entrepreneurial ventures, looking for the best ways to accelerate responsible AI practices in the larger global economy. He holds degrees from Carnegie Mellon University, MIT, and the University of California at Berkeley. In 2023, he was named one of Times Magazine's 100 most influential people in AI around the world. So let's give him a warm welcome to Dr. Andrew Ng.
Thank you so much to Shirley Guo, CEO of the Yongling Foundation. And ladies and gentlemen, your first keynote speaker today is Dr. Andrew Ng. 接下来呢，是我们今天的第一位主讲人，吴恩达博士。
Thank you, Shirley. It's good to see everyone here. What I want to do is share with you today what I see as some exciting opportunities in AI. So I've been saying for a few years that AI is the new electricity. And that's because one of the difficult things to understand about AI is a general purpose technology, meaning it's not useful just for one or two things. It's useful for a lot of different applications, like electricity. If I ask you what is electricity good for, it's almost hard to answer that question because electricity is useful for so many different things. And like electricity about 100 years ago, I think AI is now going to revolutionize every sector of the economy. What I want to do is start off with a brief description of the technology landscape, and this will then lead into a discussion of what we can all do with AI. So there's a lot of hype and excitement about AI. And I think a good way to think about AI is as a collection of tools. The two most important tools in AI are supervised learning, which is very good at labeling things, and the new entrant, generative AI. If you study AI, you may have heard of some other tools as well, but today I want to focus on just the two most important, which are supervised learning, good at labeling things, and generative AI. So supervised learning is a technology that started to work really well about 10, 15 years ago, where we could take inputs and label them with an output. Given an input A, we could compute an output B. For example, given an email, we can label it with whether or not it is spam. The most lucrative application of this I've ever worked on is probably online advertising, where all the large ad platforms can input an ad and some information about a user and label if you're likely to click on the ad. And for a single company like Google, this drives more than $100 billion a year. I see we have also Appia here, a very successful MarTech Taiwanese company also making good use of this technology. In self-driving, sorry about that. All right. In self-driving cars, we have AI that can input a picture of what's in front of your car and label it with position of the other cars, with driver assistance or self-driving. One of the projects one of my teams worked on is, given a ship route, we can label it with how much fuel it's going to consume, use that for logistics. My teams do a lot of work in manufacturing, where we can take a picture of a smartphone that's just been manufactured and tell us if there's a defect for inspection, or Given a restaurant, if you want to monitor the reputation, you can look at the restaurant review and label that as a positive or negative sentiment for reputation tracking. So one thing about AI, even supervised learning, is notice how many different applications it is useful for. And when it started to work well 10, 15 years ago, it was a lot of work for many of us to go and find and build to these applications of supervised learning. So just to walk through one concrete example, this is what building a supervised learning labeling project looks like. If you want to build a restaurant reputation monitoring system, you start by getting data, so pieces of text like, the oyster omelet. This is what jian is amazing. You say there's positive sentiment. Server was slow. There's a negative. My favorite dan bing. That's positive. And so, given thousands of data points like this, you then have your labeled data. Then you can train your AI model, and then find a cloud service to run it. And after that, you can input your best dinner nights I've ever had, and it'll say there's a positive sentiment. So this is a typical workflow of an AI supervised learning project. Now, I know there's a lot of excitement about generative AI. And I think that generative AI was set up for success with some of the early progress in supervised learning. In fact, I think the last decade was a decade of large-scale supervised learning, where starting about 10, 15 years ago, we found that if we built a very small AI model, a very small neural network, even as we fed it more and more data, it would not get much better. But when I started the Google Brain team, the primary mission I set for the team is I said, let's just build really, really large neural networks with Google's compute infrastructure. And we found that as we scaled to very, very large neural networks, we could feed it more and more data, and we just keep on getting better. I know Jensen Huang and Lisa Su were in town just recently, and I feel like GPU hardware has powered a lot of this rise of AI in the last decade. How about, if that was the last decade, I think this decade is turning out to be the decade of generative AI, which doesn't replace, but adds to the tools we have in supervised learning, where we now have tools that can input a piece of text called a prompt, and if you run it once, it may say mango shaved ice, mother's braised pork rice, or tofu. And I think that when Sam and his team released ChatGPT November, less than a year ago, it was almost a magical moment. But I want to take just a minute to demystify how the heart of large language models works. Since it seems so magical, how does it actually work? It turns out that the heart of generative AI, of these large language models, is they're built by repeatedly predicting what is the next word using supervised learning. So for example, if an AI has read on the internet a lot of text, like a sentence like, my favorite food is tomato scrambled eggs, right? 番茄炒蛋. I actually really like that. Then it can use this as data and ask, if you see my favorite food is, predict what's the next word. In this case, it is tomato, or if it sees my favorite food is tomato, what's the next word? Scrambled, and so on. If it sees my favorite tomato scrambled, what's the next word? Is eggs. And it turns out that if we train a very large AI system on a very large number of words, hundreds of billions of words, so sometimes more than 1 trillion words, then you get a large language model like ChatGPT or Bard or Google Bard or Bing Chat or others. And I think that while many of you are familiar with tools like ChatGPT as a consumer tool, and I think it's a fantastic consumer tool, there's one other revolution, which is how generative AI is changing AI application development. And I think I'm as excited, even more excited about generative AI as a developer tool, as a consumer tool. But let me show you what I mean. So if I wanted to build a restaurant sentiment review system with supervised learning, this is what I would do. I would get label data, maybe it takes a month, train an AI model, maybe it takes 3 months, deploy in the cloud, maybe that takes me 3 months. So typical realistic timeline for building a production commercial AI system is maybe 6 to 12 months. And many very good teams I worked with took about that long to build a system. But in contrast with prompting, this is what the workflow looks like. You can specify a prompt. This takes minutes, maybe hours. And then you can deploy the model in maybe hours or days. What this means is that there are a lot of AI applications that used to take me 6 months to build, that today there are hundreds of people hundreds of thousands of people, maybe millions of people that can do in 1 week what used to take me 6 months to do, and this is leading to a flourishing of AI applications. Now, I know you were not expecting me to write code in this presentation, but that's what I'm going to do. So Sam's here, I'm going to use OpenAI tools, but this is all the code it takes to write a sentiment classifier. I'm going to import some tools from OpenAI, load my API key, then, I don't know, I really enjoyed the Yonglin Foundation meeting, what came away feeling, I don't know. I've never run this before, so I really hope it works. All right, so that's the prompt. So it says, classify the text below the limit of 3 dashes as having either positive or negative sentiment. So, and then I'm actually going to run it, right? And so, oh, thank goodness that worked. But this is all the code it takes in order to build a sentiment classifier. And this is revolutionary that so many people can now, with just a few lines of code, build and deploy a pretty good AI system. One of the things I've been working on over the last many months is work with many different industry partners to teach generative AI as a developer tool. And I've been privileged to work with many of the industry experts. So OpenAI, AWS, LangChain, Lambda, Hugging Face, Google, Microsoft, Waze, and Bicycle here. Almost all the leading generative AI companies. I think we're probably working with all of them at this point, including many that have not yet been announced. And I also want to mention that key to our developer education efforts is our Taiwan engineering team. So deeplearning.ai, my teams have been working on this generative AI application. Our engineering team is actually here in Taiwan, and we couldn't have done it without them. And I hope this will be our little contribution to the Taiwan engineering ecosystem as well, and dissemination of knowledge. Now, given this technology landscape, let me share a little bit about where I think are some significant AI opportunities. The size of these circles shows what I think is the value of different AI technologies today in terms of value generated from applications compared to what the value would grow to 3 years from now. Supervised learning, really massive. For a single company like Google, worth more than $100 billion a year, and with millions of developers working on it, I think over the next 3 years, which is a very short time horizon, may double, go from massive to maybe even more massive. Generative AI, very exciting, but it's small right now, but I think it will much more than double over the next 3 years. Sometimes people see this slide and they think I'm not excited about generative AI. No, I'm very excited about generative AI. I think it just will take time to figure out and build the applications, and 3 years is a very short time. If it continues to grow at this rate, then in 6 years, maybe it'll be even vastly bigger. But the light shaded region is where I think there are a lot of opportunities for developers, big companies, startups, everyone, to identify and build exciting opportunities. And one thing I hope you take away from this part of the presentation is AI technologies are general purpose technologies. Supervised learning and generative AI, they're both general purpose technologies. And this means they're useful for many different tasks, and many applications remain to be identified and built. But sometimes you get asked about this. But there's one caveat, which is that there will be fads along the way. I'm not sure how many of you remember the app Lensa. This was the app that you can upload 10, 15 pictures of yourself, and it'll draw a cool picture of you as a scientist or an astronaut. And so it was a really good product. Its revenues took off like that through last December, and then it did that. And I think this is because Lensa was the first of, unfortunately, what may be multiple fads. That was a good idea, but wasn't a long-term sustainable business. When I think about Lensa, I'm reminded of when Steve Jobs, as well as Terry, gave us this. And then there were fads too. Developers built an app for $199 US to do this, to turn on the flashlight. And it was a good idea, but this too was a fad that wasn't a long-term sustainable business. But on the flip side, the iPhone also allowed other smart entrepreneurs to build long-term sustainable businesses like Uber and Airbnb and Tinder. And I think on top of generative AI platforms, viewed as a developer tool, we have opportunities to do that too, and that's what I'm excited about. So the first trend is generative AI as AI as a general purpose technology. There's just one more trend I want to share with you, and I only share this because I think this will impact many industries that Taiwan is strong in, which is, and this addresses why AI isn't more widespread yet, right? So a bunch of us, we've been talking about AI for 10, 15 years now, but its value is still very concentrated in consumer internet. So why is that? If you were to take all current and potential projects, current and potential AI projects, and sort them in decreasing order of value, you get a curve that looks like this, where to the left are the most valuable projects like online advertising and web search, where you can write one AI piece of software, if you're Google, say, and apply that to 1 billion users and generate massive economic value. So about 10, 15 years ago, my friends and I figured out a recipe for how to build projects like that. We hire 100 engineers, have them all work on one project, apply it to 100 million or 1 billion users, and this turns out to be very valuable. But once you go outside the internet sector, almost no one has 100 million users that you can apply one AI system to. Instead, these are the types of projects I've been working on. We're working with a factory that makes pizzas, and we're taking pictures of the pizza, and the factory needed to take pictures of the pizza to make sure that the cheese is evenly spread. This turns out to be about a $5 million project for the factory, but you can't hire 100 engineers to work on a $5 million project. Or agriculture. I know there's a lot of agriculture in Taiwan, obviously, but we're working with a company that makes agriculture machinery, and we figured out that if we can find out how tall the wheat is with cameras, with computer vision, and chop off the wheat at the right height, then we get more food for the farmer to sell, and it's better for the environment. But this is another $5 billion project that the old recipe is not economical for. Or inspection, material grading, a lot of these $5 billion projects. So whereas to the left of this curve is a small number of billion-dollar projects or $100 million projects, we know how to do that. In other sectors, we see tens of thousands of these $5 million projects, and the struggle has been, how do we get all of these tens of thousands of projects economically built? Fortunately, the trend in AI has been toward better tools, specifically low-code, sometimes no-code tools that enable the user to do the customization. So what this means is, instead of me having to do work to figure out what to do with pictures of pizza, now the IT department of the pizza factory can build an AI system using their own images and realize that $5 million worth of value. And by the way, these pictures of pizza, they don't exist on the internet. They're proprietary to the factory, and so Google and Bing do not have access to these pictures either. And the key technology to do this is prompting, as well as a technology called data-centric AI, in which you can let the, say, IT department of the factory write prompts to provide data, and this lowers the barrier. And I'm sharing this because I think this is an important part of the recipe to take a lot of the value of AI, which has so far been concentrated in consumer software internet, and push it to the rest of the economy, which is even bigger, than the tech industry. So, where are the opportunities? I felt 5 years ago that many valuable opportunities are now possible in AI because of supervised learning, but I feel even more strongly about it because of generative AI. And the puzzle I wanted to solve 5 years ago was, how do I get many of these projects built? And even though I had led AI teams in big companies like Google and Baidu, I couldn't imagine how I could operate a team inside a big tech company to go after the very diverse set of opportunities that AI now makes possible. I think starting new companies is an efficient way to do this, which is why I started AI Fund, which is a venture studio. But of course, to incumbent companies, there are also many opportunities to integrate AI into existing workflows. And often incumbent companies have a huge distribution advantage. But concretely, where are the opportunities? This is what I think of as the AI stack. At the lowest level is the hardware layer. And I know Jensen Huang and Lisa Su were just in town. I think semiconductor industry is very capital intensive, very concentrated. Clearly TSMC, UMC are doing very well. I personally don't play there because of how capital intensive and how concentrated it is. But clearly in Taiwan also, building servers is a great business. On top of that are the cloud infrastructure, also very capital intensive, very concentrated, so I tend not to play there myself. And then there are the developer tools, including OpenAI, right? The API part of OpenAI. I see the developer tool market as potentially with some huge winners, but also hyper-competitive. In fact, look at all the startups chasing OpenAI. So I personally tend to play here only when I have a significant technology advantage, because I think that gives you the right to have a shot at building a sustainable platform, to be one of the huge winners. And even though a lot of the media attention is on the infrastructure and tooling layer, we saw this with every wave of technology. When SaaS came up, all the attention was in the technology layer. It turns out that for the infrastructure and tooling layer to be successful, there's one other layer that needs to be even more successful, and that's the application layer. Because for the tools and infrastructure to be successful, the applications have to generate even more revenue to pay them, to make this whole, to make all the economics work. So maybe one example, I was talking the other day on the upper right with the CEO of Amorai, which is a company that applies AI to romantic relationship coaching. And what do I feel like I'm an AI guy. I know nothing about romance, right? And if you don't believe me, you can ask my wife, and she will confirm that I know nothing about romance. But when my Team AI Fund decided we wanted to do something applying AI to romance, we wound up partnering with the former CEO of Tinder, Renata Nyborg, and who knows much more in a systematic way about relationships than anyone else I know. And with my team supplying the AI expertise and her supplying the relationship expertise, we're able to build something very unique. And at the application layer, I seem to keep on finding more and more opportunities where it looks like there's a huge market need, but the intensity of the competition is just quite low. So over the last few years, AI Fund has actually refined our process of building startups. I'm going to share with you what this process is, because I think there'll be many great startups to be built, hopefully here in Taiwan as well. But we always start off with the idea. Often we partners suggest ideas to us. And I want to share one case study, which is one of our investors, Mitsui, operates a line of ships. And so they came and suggested to me, they said, hey, Andrew, you should use AI to make shipping more fuel efficient. And this is one of those ideas that I would never have come up with myself, because I've been on a boat, but what do I know about global maritime shipping? But so they suggest the idea to us, and in a typical process, we spend up to a month validating the idea for market need and technical feasibility. And if it passes that, we then recruit a CEO. We recruited Dylan Cowles, fantastic CEO with one exit before, to work with us to build the company. We then spend 3 months to do deep customer validation, build a technical prototype, and if the company survives this stage, it survives this stage 2/3 of the time, we then fund it. That gives it capital to build an executive team, get real customers, and is then in the position to go and raise additional capital and be well on its way. So today, Bering is steering hundreds of ships, many hundreds of ships on the high seas, like Google Maps for ships, where the software, AI software, tells a ship where to go to get to the destination on time and with about 10% less fuel, thus saving about $500,000 per ship, and also reducing carbon emissions. And this startup would not have existed if Mitsui, that knows this idea, hadn't suggested this to us. And I find that I've learned that my swim lane is AI. I don't try to be expert in relationships and shipping and everything else. I try to be an expert in AI and instead work with partners on all of these different application sectors to find exciting opportunities to go after. And certainly while I'm in Taiwan, I'll be here for a few days. Hopefully there'll be opportunities to explore locally meaningful ideas to Taiwan as well. I've just one last slide, and I'll wrap up, which is to touch on risks and social impact. So there are many risks of AI. I think the biggest risks of AI are bias, fairness, and accuracy. But AI technology is rapidly improving and become much safer. And I think AI will disrupt jobs as well, even though we create a lot of value. And I think we have an obligation to take care of the people whose jobs are disrupted. And there is excitement about AGI, artificial general intelligence. The most widely accepted definition of AGI is AI that can do any intellectual task that any human can. And I think AGI is still many decades away. There are different opinions on that. But if you want AI to do any intellectual task a human can, I think that's still quite far away. But I hope we will get there. And then lastly, I know even last couple of days, yesterday, even today in Taiwan, some people are asking me about extinction risk. And I think AI leading to human extinction risk is very overhyped. I hope that maybe in our lifetimes, there'll be AI smarter than any of us. It's already smarter than any of us in some ways. But humanity has lots of experience controlling things far more powerful than ourselves, like corporations and nation states. And we've managed to make it okay. So I don't really doubt our ability to control AI. And lastly, when it comes to the real existential risk to humanity, things like the next pandemic, fingers crossed, hopefully not, or climate change leading to massive depopulation of parts of the planet, or another asteroid, lower chance, doing to us what it did to the dinosaurs, wipe out the dinosaurs. I think that if we look at the real existential risk to humanity, AI would be a key part of the solution. So rather than trying to make AI go slower, if we want humanity to survive and thrive for the next 1,000 years, I would rather make AI go as fast as possible. So with that, let me say thank you all very much.
Thank you so much to Dr. Andrew Ng for your very, very informative and comprehensive talk. Thank you so much. 非常谢谢吴文达博士带来非常精彩的分享。Andrew, thank you so much for taking us on a deep dive into the opportunities in AI. 那接下来呢，在我们炉边对谈之前，想要请摄影师先到舞台上，帮今天参加我们 AI 大师论坛的所有贵宾拍一张大合照。And before we move on to the fireside chat, we're going to have our photographers take a photo of all of you who joined us for the AI Master Forum today. Okay, everybody, please look at our